The geology versus astronomy talk. Uh, when I was in the Marine Corps, I uh, I went to Camp Hansen for my first real duty station. That's in Okinawa, Japan. And instead of going back to the barracks every day and playing video games like a lot of my buddies did, I decided to take at least one class at the University of Maryland University College, Asia. They had a little branch of the campus there where you could take a few classes if you wanted to. And of course, while you're in the service, tuition was 100% free. So basically, I just signed up for a free college class. The the class was in geology. So after I got out of work, which was, basically barracks life, I still had my camis on and I walked down to the little building where the class was, and I took a simple geology class. And the geology class was condensed, so I think I remember it being only 3 months long because it was 2 hours on Tuesday and 2 hours on a Thursday after work for each class. So I think it only took me like 3 months to take that class. I got an A in it, but that wasn't the point. The point is that I learned about the Earth, and I learned about magma plumes and what they consider to be plate tectonics, and the age of the Earth, and mountain ranges and beaches, and I remember a lot about it. And it was my first real college course where I could go ahead and explore like my mind and how I could absorb information in in that type of setting. And it was really good for me. And it also had consequences that actually were going to reach into my future all the way to now. Now, keep in mind, this one single geology class I took was in 2004, before I went to Florida State in 2007. So it was a full 3 years before I actually attended college full time after I got out of the service, which was from '03 to '07. Now, the reason why I'm talking about this is because the consequences of just taking one simple class had far reaching effects beyond what I previously considered to be possible. Now, those consequences were the fact that I had learned that the Earth had a solid inner core made out of iron, and then it had, its layers of all the other elements, and it had a silicon crust, and it had an atmosphere full of oxygen and nitrogen, and it had a thin ocean water layer on top of that. Now, in geology, you say it's the study of the Earth. I think, though, one of the greatest mistakes that astronomers and geologists make is compartmentalizing the Earth as being the study of the Earth and the Earth alone. Because a good analogy would be to say, okay, you have a glass of water. Now, mind you, it's not the entire Lake Superior or Lake Huron or Lake Erie, but that one glass of water, study that water, it can represent an entire lake. So you don't have to actually go to the lake and study all the water inside the lake to understand what water does. All you need is a little glass of water. And it's the same with the Earth. To understand the stars, you don't need to go out there and take samples of every single star out there. All you need to do is go outside and pick up a rock. Because that's what the Earth is. It's an ancient star. It's a very, very, very old star at the very end of its evolution. Thus, the differentiation between stars and planets was a man-made construct. There was no difference. It was a construct designed to support the status quo of the sun being bright as a star, and the other objects which don't shine as planets. Little do they realize that stars don't shine forever. They cool and they die. And it should have been obvious to them that when stars cool and die, they don't shine anymore. They become planets. Thus, the study of the Earth isn't just geology. The study of the Earth is astronomy and astrophysics. The Earth is an astronomical object. It's floating in outer space, I guarantee you that. But a lot of scientists these days, they just compartmentalize. They say, oh, well, plate tectonics only works on Earth, and Earth is the only one with water oceans, and Earth is the only one with atmosphere. No. No, no, no. Everything on the Earth is ubiquitous across the entire universe. Everything. Stars all have rocks and minerals. The old ones and the young ones are all made of plasma. The middle-aged ones are all gaseous and still differentiating their interiors as they cool and die and form the little hard rocky ball in the center of them, like a pearl inside of an oyster. But basically, I should have really, really got that point across to a lot of my viewers earlier, is that a big issue with modern science is that they take fields of study, such as chemistry or biology or physics or math, and they compartmentalize it. They say, well, this is geology, or this is astrophysics, and this is mathematics, and this is biology, and this is, and they put it into little groups of understanding, and they focus in on those little groups. But what they don't realize is that focusing in on that little itty-bitty study, that's not going to bring the grand understanding that you're looking for. What they should be doing is going next door. Say you're a geologist. They should be going next door to the astronomy department and saying, hey, check this out. Look what I did here. What do you think about this? And the physicists should be going to the biology department and saying, what do you think about this? What's this all about? Because the great discoveries now are going to have to be, what's that word called? They're going to have to be, there's a word for it, I can't remember, but they're going to have to mix. These studies have to mix. And if we don't allow mixing between the disciplines, then we're not going to have the great understanding that we want. Period. Everybody's going to be so specialized in their own little fields, so focused in on some little aspect of whatever it is that they're studying, and they're going to completely miss the big picture. Now, this theory I was developing is a play on that missing the big picture. Because you have geologists, they look at mountains and they study rocks and minerals, and they don't realize that what they're standing on is an astronomical object. By studying the mountains, you're doing astronomy. You're doing astrophysics. And the astronomers, well, they look through the telescopes and they think, oh, well, this is astronomy, But they don't realize that they don't have to look through the telescopes. All they have to do is look at the ground they're walking on. All they have to do is grab some samples of dirt and study dirt, and they'll have more understanding of the stars than any astronomer ever could by looking through a telescope. But I guess we'll just have to come full circle with that. I know some people are going to be confused about this talk, but I'm sure if you actually read the theory, you would be a little less confused as to what's happening right now. Alright, today is February 12th, 2015. I hope people can understand that real science is interdisciplinary. That's the word. It means you take multiple disciplines and you combine them. Just taking one discipline and then trying to understand everything inside of that discipline is only a very limited perception of reality. In order to really understand the world around you, you need to study all the sciences. You need to do all the work. And you need to keep an open mind to make connections between those sciences. From astronomy to geology to physics, biology, and chemistry. You have to mix them. You have to mix them up. That's the only way we're going to get real big picture progress. Alright.